Okay, hi guys, this is the notes or just really example problems for solving right triangle sides of right triangles using trigonometry. Um, so we got 4 examples here we want to go through. Really, there's no new concepts. The concepts were all done in the last part about the trigonometric ratios. We're just simply now using the trigonometric ratios to solve for missing sides here. All right. So the first thing we want to do is label the sides of your triangle. Okay, so the first thing I would do is label your hypotenuse. Your hypotenuse is across from the right angle, right? So here's your hypotenuse. Okay. Second thing I would do is circle the angle we're looking at. So the angle where we have some value or a symbol, the angle we want to look at. So in this case, it's going to be the 66 degrees, which is B. Remember, opposite is across, so X is going to be opposite. And then BC is going to be adjacent, but we don't have any information there. So we're working with opposite and adjacent. So here we have here we have opposite and we have hypotenuse. Okay, so we have SOHCAHTOA, right, our mnemonic we're going to use. Okay, we have opposite, that's O and H. So we're looking for the one with O and H. It's going to be sine. So this is the equation we're going to use. Sine of the angle is going to equal the length of the opposite side over the hypotenuse. Okay, so our angle is 66. So we're going to plug that in here. So it's going to be the sine of the angle, which in this case is 66 degrees, is going to be equal to the opposite side over the hypotenuse. Okay, so that's going to be the sine of 66. It's going to be equal to the opposite side is x, and the hypotenuse is 3. So x over 3. And then we're simply trying to solve for x. So here we're going to try and get x by itself. In order to do that, we need to multiply by 3. Right now we have x divided by 3, so we got to do the inverse operation, which is multiplication. So we multiply both sides by 3. And we get 3 times the sine of 66 equals x. So we go over to our calculator. We make sure whatever calculator we're using is in degrees. We're going to do sine. So right now, see, I'm in radians, so I need to switch it over to degrees. So we're working with degrees right now. You got to make sure whatever calculator you're using is in degrees. So sine of 66 degrees, well, let me start over. We had 3 times sine of 66 degrees, so let's just do it that way. 3 times the sine of 66 degrees, enter, tells us 2.74, so we're going to put 2.74 approximately equals x. Okay, you can put the answer either way. I don't care which way you do it. Leave it as 3 times sine of 66, or put it as an estimated decimal. 2.74 is fine. Okay, so that's the first one. Second one here, again, first step is to label your hypotenuse. I would always do that first. So across from the right angle is AB, that's our hypotenuse. The angle we're looking at is the 75. Across from that is your opposite side. And then next to that would be your adjacent side, so AC would be adjacent. So again, here we're looking at opposite and hypotenuse. Okay, so that means we're dealing with the O and the H, right? SOHCAHTOA. We're looking for the O and the H. That's going to be sine. So again, sine of our angle, so sine of 75 degrees. is going to be equal to opposite over hypotenuse. So opposite over hypotenuse. Okay. It's going to be sine 75. Okay, the opposite side is 6. The hypotenuse is x. Okay, so this one's a little different because in the first one, the x was in the numerator. Over here, our x is in the denominator, but it's fine. It's still the same process. We're still trying to solve for x. So the first thing we need to do is get x out of the denominator. So we need to multiply both sides by x. This way the x's cancel. So we have x times sine 75 equals 6. Okay. And then, again, we still want to get x by itself. So now we need to divide both sides by sine 75. Right, and then this side also by sine 75. Okay, so we get x equals, and then we can go over to our right? This cancels out. Then we can go over to our calculator on the other one. We want to make sure we're in degrees, but then we want to do 6 divided by the sine of 75. We hit enter, and that's going to give us 6.21. So it's going to be approximately, right? Approximately, what was it? 6.21? 6.21. Okay. And just as a reminder, remember the hypotenuse is the longest side, so it makes sense that this one would be a little longer than one of the legs here. Okay. And our process for all these is exactly the same. So on the next one, here's our third one. Again, you want to label the hypotenuse first. So here's your hypotenuse. Okay. Circle the angle in question. Opposite is across, adjacent is next to. So this 13 here is adjacent. Okay, if we look at SOHCAHTOA, we have hypotenuse and adjacent, so that's H and A. So we're going to use the ka here, which is cosine, right? So our angle is 52, so we're going to use the cosine of 52. And that's going to equal your adjacent side, right? Which I guess we can abbreviate it here. Sorry to do an extra step. Adjacent over hypotenuse. All right, so cosine 52. The adjacent side is 13. The hypotenuse is x. So cosine of 52 equals 13 over x. And then we want to solve for x. So again, we got to get x by itself. So the first thing we have to do is get it out of the denominator. So we multiply both sides by x. We get x times cosine 52 equals 13. And then we can divide both sides by the cosine of 52. Okay. Make sure you always put the parentheses around the angle, because remember that's not separate from the cosine. It's the cosine of that angle. That's the input, the angle that you're inputting into the cosine function. Okay, so we get x equals 13 divided by cosine of 52. So we can go to the calculator. 13 divided by cosine 52. Enter, and it tells us 21.16, right? So or 12, so we round that to 21.12. Okay, and again, it's approximately equal. It's not exactly equal, but it's approximately equal to 21.12. Right, and then our last example here. So first thing you want to do is label the hypotenuse. So hypotenuse is across from the right angle. So here's our hypotenuse. We don't have a value here though. Second thing you want to do is circle the angle in question. Okay. Across from that angle is opposite. Next to that angle is adjacent. So 8 is opposite, x is adjacent. So we have O and A, opposite and adjacent. So if we look at our SOHCAHTOA, right, O and A, that's going to be the TOA part, which is your tangent. So tangent of theta, or the angle, is going to be equal to the opposite over the adjacent. So tangent 52, sorry, it's 51. It's going to be equal to opposite over adjacent. Okay, so tangent 51, opposite is 8, adjacent is x, right? And then we want to get x by itself, so we multiply both sides by x. So x times tangent 51 equals 8, and then you want to divide by the tangent of 51 on both sides. So that cancels. And we're left with x equals, and we got to go over to the calculator. We can make sure it's in degrees. What was it? 8 divided by tangent 51. 8 divided by tangent 51 equals 8.56. So again, approximately 8.56. All right. So there are a couple things to remember. First, label your hypotenuse. Then I would circle the angle you're dealing with, and then label the side across from it opposite and the side next to it adjacent. Use SOHCAHTOA to pick which function you're using. Are you using sine, cosine, or tangent? If you have an opposite and a hypotenuse, you're using sine. If you have an adjacent and a hypotenuse, you're using cosine. If you have an opposite and adjacent, you're using tangent. Once you know your function, write your equation, and then you got to solve for x. If x is in the numerator, you simply multiply both sides by the denominator. If x is in the denominator, you got to multiply both sides by x, and then divide both sides by the sine, the cosine, or the tangent. When you use a calculator, make sure you are in degrees. Okay. There's more Khan Academy videos going over examples. If this was not clear enough, again, we'll be doing Google Meets every weeknight. And you can text me on Remind or email me whenever you have questions.